Let's bring it in. Cut the chatter. I'll wait for everyone.
What would you upset Ellie? You put hand sanitizer on.
You guys just don't know how to show your mouse.
Do I have a new paper, Mr. Wood? There's hand sanitizer all
All right, so I handed out a paper. It's the Hyperbola paper. So you guys should all have that in front of you. If you don't, you can come up and get one. It also means that someone stole yours, so you should find who did that. I heard them. Okay. The main thing I want you guys to look at on this paper is the graph at the bottom. That's the most important part. The rest, we'll talk about the vocabulary part for the rest because the vocabulary is important for us to know what we're talking about when we discuss hyperbolas. Paper right here. There you go. So take note of the bottom. But first, what I want to do is I want to show you how hyperbolas look a lot like ellipses, or the equations do anyways. So recall, thank you, for ellipses, what equation did we have? What was the equation of an ellipse?
X minus h.
X minus h squared over a.
Adam has it. Wow.
Y minus k squared over b squared.
Sophia!
Alright. I know everyone's crazy. I know we're hungry for lunch, and let's settle it down. Let's focus in. Got a lot of stuff to learn today, so I need you guys to focus on this. It's important. And then if you don't focus today, you're going to be lost tomorrow when you guys start doing practice. So, alright. Ellipses. We had this equation. It looks very similar to what we're going to see the equations are for hyperbolas today. For hyperbolas, we have two cases, actually. So there's two standard forms for hyperbolas. The first case is if it's a horizontal hyperbola, which is this picture here. It's when you have it opening up to the left and, yeah, to the right and to the left. So the horizontal case is going to look almost identical to this, but instead of adding, we're going to take the difference of the two terms. But they're going to be the same terms. So x minus h squared over a squared. So now we're subtracting y minus k squared over b squared equals 1. So almost the exact same, right? We're just subtracting. For the vertical case, though, so sorry, I should label it. This is horizontal case, and then vertical case. What we're going to do is we're going to flip the y minus k, or switch the y minus k with the x minus h. So one thing to note is the a squared term will stay where it is. We always put the a squared term with the positive term. And the b squared term always goes with the negative term. Okay, so here we have y minus k squared over a squared, and then here we have it over b squared. So the a always goes with the positive term, which we usually write as the first term. The b goes with the negative term, and h will always stick around with x, just like k will always stick around with y. And can you guys guess where the center will be?
HK.
HK, as usual. Good. So these are our equations. So let's go back to this paper and talk about a few things. So on the horizontal one, here they wrote the equation without the h and the k, but you can just plug in your h and k to both of them, and it's the same equation. So on this one, let's talk about each thing. So we have a center, we said, which was hk, right? And I'm going to write that down over here as well. That marker does not work. We have a center at hk, which is really important. The way to find the center, it's obviously the midpoint between what we call the vertexes, or the vertices, each vertex. So you have two vertices, why do I keep saying vertex? One here, and then on the horizontal one you have a vertex here, and you have a vertex here. So if you take the midpoint between the two vertices, that's your center. It won't always be at the origin. Today we're mostly going to stick around at the origin because it's easier. But one thing you can do is if you have say you have one that's off center a little bit. Let's say, as an example, let's say you have a point at 1, 4, and then another point at 1, negative 4. So this is 1, 4, the other one's 1, negative 4. So you have these 2 points. What you know is that if you take the midpoint between those two, you'll find the center. So I heard it over there like 5 times. 1, 0, which would be here in the middle. So you just have to take the midpoint to find the center. Today, like I said, today it'll be at the origin. And then you'll notice that when you have it at the origin, h will be 0, k will be 0. So you'll end up with the equations that are on your paper, where it just says x squared and y squared. Yeah. Another thing to note, each vertex, we say it has the point 0a or 0, negative a. So, I'm going to write that down. For vertices, we have vertices at 0a and 0, negative a. And this is for the vertical example. So I'm going to put a big V there for vertical. So for the vertical hyperbola, we have vertices at 0a and 0, negative a. Then for the horizontal one, we have vertices at a0 and negative a0. And that's h for horizontal. And then you'll see that on the paper, on the graph. You see your vertice here is at a0, and then this one up here is 0a for the vertical one. And the easy way to remember which one it is because you have a 0 in the x value and an a in the y value. I hope you guys are talking about math back there. You have a 0 in the x value, an a in the y value, and that means it's going to be your vertical one. If a is in the y value, it's going to be vertical. If a is x value, it's going to be horizontal. So we went over vertices, we went over the center. We also have 2 focuses. Foci is how we say it. One here and one here. We're going to talk about those a little bit more tomorrow. But one thing to note about the foci, which is kind of cool. Do you guys remember when Mrs. Goodwin went over the ellipse and she said you have these 2 focuses and she had the string? And she said that if you choose any point on the ellipse, it'll always be the same distance as, say we choose this point, it'll be D1, we'll label that, plus D2. And for any D1 and D2, so if you take another point over here, in blue we'll do, and you label that one D1, D2, this D1 plus D2 is the same as that D1 plus D2. You guys remember that? So hyperbolas actually have a really similar property, which is kind of weird because they go away from each other, so you wouldn't expect it. But it's actually the difference instead of the sum, just like the equation says, right? Similar to the equation. It's going to be the difference instead of the sum. I'll do it over here again. So if we have this hyperbola, and we have some, that's not even like centered, but that's okay. So we have 2 foci. What we can say is that the difference between D1 and D2, so I'm going to choose this point, and I'm going to say this is D1, and then the distance to the second foci is D2. So what I can say is that the absolute value, and actually let me draw, and then I'll choose another point, I'll choose it over here, and I'll make this D3, and this one will be D4. Sound good? So what I can say is that the absolute value of D1 minus D2 is equal to the absolute value of D3 minus D4.
Wait,
Yeah.
why would it be D4 minus D3?
It could be. Remember when I explained how the difference between 2 values is the same if you take the absolute value? Like 4 minus 2 is 2, and 2 minus 4 is negative 2, but the absolute value is always the same.
Oh, I can show
So if you want, you can do D4 minus D3, that's fine.
Yeah.
Yeah, so the difference is always the same if it's the absolute value. So the point being, instead of the sum like we did with the ellipses, D1 and D2, it's going to be the difference between the 2. So similar property, which is unique and somewhat cool. I think it's cool. So we have the foci, which Mrs. Goodwin is going to talk about more tomorrow on how to find the foci, which ends up being the Pythagorean theorem. Spoilers, sorry. Vertex. And then the last thing we really need to talk about is the asymptotes. What kind of asymptotes are those?
Slant, oblique.
Slant, oblique, good. Oh yeah, and the other thing is that the actual line of the hyperbola there's two lines here. We call those branches. So this is the left branch, the right branch, the top branch, the bottom branch. So those are called branches. Yeah. Oh, and the transverse axis. We have two axes. This is the last vocabulary term, I promise. We have two axes on a hyperbola. There's the transverse axis is the axis that cuts through the center and cuts through both vertices. So this is called the transverse axis. So on the vertical case, it follows the y-axis, and on the horizontal case, it follows the x-axis. Then the other axis is called the conjugate axis, which does not cut through either branch. It goes perpendicular to the transverse axis. Makes sense?
Center. No.
Yeah, it goes through at the center, sorry.
I'm so confused right now.
It's just vocabulary. So transverse axis goes through.
Yeah.
Yeah, the transverse axis is axis of symmetry also.
Okay.
That's a good point. And then the conjugate axis just crosses it at the center and it's perpendicular. So, okay, vocabulary's out of the way. We have branches. Let's talk about asymptotes, because asymptotes are fun. All right. So what we can do, from the standard form, we can derive our asymptotes and figure out what they are, which is actually pretty cool. I keep saying it's cool. It's cool. I love, like, as a student, I used to hate like the qualitative approach to things and like deriving formulas and trying to figure out like how they got, like when they first figured out these formulas, how they got to it. So now I find that stuff really awesome. So I hope some people find it awesome. So. Okay, here we go. So let's do the horizontal case first. They're pointing at you and laughing. So. What did she do?
I think she was just, never mind.
Okay. So for the horizontal case, I'm going to rewrite it. Actually, so one thing to note, like I said, today we're going to assume the center is 0. When you assume the center is 0, you end up with just x squared over a squared minus y squared over b squared equals 1. So when hk is 0, you end up with this, right? This is the horizontal equation. And if we know the center is at 0, we can do that. If the center is not at 0, if we know that h and k have some value, what we can do is make the shift, then draw our center at whatever point it is at hk. And then you can write this equation out and still solve it this way, just knowing that your center is not the origin, it's whatever your center was. Does that make sense?
Yeah.
Okay, you can, yeah, you shift it and then you treat it like it's a normal origin-based hyperbola. So that's what we're going to do. Whether or not hk is 0, it doesn't matter. We plotted our center, and now we're going to mess with this equation. So what I want to do, you guys remember slant asymptotes are always a linear function. They're always y equals mx plus b form. I know you guys do. You guys did the best with that, I think. So what we can do is we can solve for y, and it's going to output a couple equations for us, and those are actually going to be both of our asymptotes. There's always two asymptotes, as you guys see on your graph. It always makes an x of some sort. Might have a different slope, but nonetheless. So we can solve for y here. So I'm going to subtract this x squared over a squared from both sides. So we're going to get negative y squared over b squared equals 1 minus x squared over a squared. Then I'm going to try to get y by itself so I can multiply by negative b squared on both sides. So it's going to cancel on this side and we're going to end up with a y squared. And then we have to distribute it to both of these terms. So 1 times negative b squared is just negative b squared. And then negative b squared times this x squared, negative x squared over a squared. I'm going to pull the a squared out, so I'm going to rewrite this real quick. I'm going to write it as 1 over a squared times x squared. And then we're multiplying by b squared, negative b squared. So the negatives will cancel. I'm going to put b squared over the a squared, and then times x squared. So it'll end up like this, b squared over a squared times x squared. Right? Confusing?
Yeah. Really.
I'm just moving things around, yeah.
How does you get negative 1 over a squared?
It's from here. So we have, I'll just pull it over and do it again. So we have 1 minus x squared over a squared. Is x squared over a squared, isn't that the same thing as 1 over a squared times x squared? Because you can just move, if it's in the numerator, you can just move it off to the side. Put it in parentheses, that's your coefficient. Yes, no?
Yeah.
Okay, so that's all I'm doing there. And then all we have to do is we're multiplying the whole right side by negative b squared. So 1 times negative b squared is negative b squared. Minus this whole thing times negative b squared, which is what we did here. So negative b squared, the negatives cancel, right? So it's going to end up being a plus. And then you just have b squared times this, 1 over a squared. So you can just put it in the numerator, right? Because you're multiplying. So b squared over a squared times x squared. If it helps you, you can leave the x squared in the numerator. I like to pull it out because it ends up being the coefficient, which looks nice. Don't worry too much about this. I'm deriving the formulas of the asymptotes, so it's not a huge deal if the algebra is kind of messy. So back to here, negative b plus, what was it, b squared over a squared times x squared. So we have this, and now the only thing left to do to solve for y is take the square root. So y equals the square root of, I'm going to flip the terms, just subtract b squared. So I'm just swapping the order. So b squared over a squared times x squared minus b squared. This is your coefficient of x squared. So we have this. We have an equation for y. It's kind of messy. It doesn't look nice. But that's okay. Notice there's a lot of square terms. So we can see that we might be able to manipulate it a little bit to give us an equation that looks like a linear equation, right? Because ultimately we're looking for something in the form y equals mx plus b. So, you guys remember when we talked a little bit about limits? When we talked we're like calculus preview limits. We talk about the end behavior of a graph as it approaches, as x goes to infinity, so really far to the right, as x goes to negative infinity, really far to the left. So we mentioned that. You can write it formally as like the limit as x goes to infinity, but we don't need to worry about the formality of it. Just know that when we're talking about asymptotes, we're talking about what happens when the graph goes really far left and what happens when the graph goes really far to the right. So with that in mind, let's look at this, and we can say, what happens when x gets really, 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 really big? Notice that a and b are constants, right? A and b aren't going to change. They're going to be whatever the initial conditions of the problem are. So they'll say, oh, your vertice is at whatever 3, like 0, 3. That would mean your a value is 3. So a and b are constants. They get squared, and then they never change again. So you could give them numbers. You could say b is 3, a is 2, whatever it is, right? But x squared is going to get really big really fast, right? Because it's a squared x. So when x is 1,000,000, x squared is going to be 1,000,000,000,000. It's going to be really, really, really big. So it goes to infinity, because we're talking about the limits. So as it goes to infinity, the end behavior, this equals infinity, right? This, like, inside the square root, we've got square root of, like, infinity, basically, right? Because we're just saying the square root of, like, some constant, like, or b over a, b squared over a squared, times, we're saying let x go to infinity, so times infinity, whatever, minus b squared. So if we have some constant times infinity, what's that? It's still infinity, because infinity, it's just like a slightly larger infinity, but that doesn't make a difference. Infinity is infinity. And then infinity minus infinity minus 3 is what? It's still infinity. So the point is, inside here, we've got infinity times some number, but then if we're subtracting out like 3, or just any constant, I mean, you could subtract out 1,000,000, but 1,000,000 compared to infinity is like an ant compared to an elephant. It's there, but it's so small that it's kind of irrelevant. So the point I'm getting at is that we could say, well, y isn't equal to this. Like, let's just remove the negative b squared. Y is not equal to that, but it's close, right? as x gets really big or really small, it gets really close to being equal to this. So we could say y is approximately equal to, with the squiggly equal sign, that means approximately equal to the square root of b squared over a squared times x squared, period. Right? We can take out this really small constant, relatively small, and say, well, it's approximately equal to this. And now look, we can take the square root of this really easily, can't we? Because b over a times x times b over a times x is equal to b squared over a squared times x squared. So this is just a perfect square. So that gives us two equations. Y is approximately equal to plus or minus b over a times x. And what that means is that our vertical asymptotes, our oblique asymptotes of the horizontal case, because we're still doing the horizontal case, our oblique asymptotes are equal to y equals b over a x and y equals negative b over a x. So these are your asymptotes. And what's interesting though, so if you graph this, we said it's a horizontal asymptote and we have it's a horizontal hyperbola and we have some slant asymptotes. So we could say this one is y equals b over a x, right? That's this line. So if we say that, couldn't we, if we're looking back at this, we know that we made an approximation, right? These asymptotes are like an approximation of the value as x gets really big. But we took away this term, and this term is subtracting like a small value. So wouldn't we then say that our graph is slightly below that approximation we made? Because we took away this small value that we subtracted. So we're supposed to subtract this value. So if we did, we wouldn't be on the asymptote, we'd be slightly below it. And then notice how if we're slightly below the asymptote, it's going to end up looking like this. Because it can't be above it, it can't go through it. Right? So it kind of proves to you that, yeah, it's a horizontal asymptote. Because the approximation is just below, or the b value that we took away was just below the approximation. But that's not too important. So, any questions about that? I know it's kind of like the qualitative part is kind of confusing. Yeah.
What you boxed is the formula for x.
Right here.
Yeah.
This is the main takeaway.
So that is the formula.
This is the formula for your horizontal, I'm going to write it over here. For your horizontal hyperbolas, these are your asymptotes. And we'll do the vertical ones with the same process really quickly. So I'm going to write over here, asymptotes are going to be y equals plus or minus b over a times x, and that's going to be the horizontal case.
For vertical, you just switch it back to x. Or is it
You're actually still going to find y, but notice that the
So
equation
A
is
over
different.
B.
It's going to be over a over b, yes. Good spoilers, but we're still going to do it, so you can see why. Okay, so this one is vertical. So for the vertical case, we're swapping the y and the x, right? The a still stays on the left. So y squared over a squared minus x squared over b squared equals 1. That's our horizontal equation. We're still assuming the center is at 0, 0. Or, yeah, the center is at 0, 0, so h and k are both 0. Or we're assuming that we already shifted for our center, and now we can solve for this. So same thing, solving for y. This one looks a little prettier because there's less negative signs. So y squared over a squared equals, I'm going to add this to both sides. So x squared over b squared plus 1. Then I'm going to multiply by a squared on both sides. So y squared, the a squareds cancel. And then I'm going to do the same thing. I multiplied a squared. I'll leave it in the numerator this time so you guys can see that. B squared, right? We're multiplying by a squared. Plus 1 times a squared is just a squared. Then we can rewrite this as the coefficient of x if we want to. And I'm going to take the square root, both at the same time. Brace yourselves. So y equals the square root of, and I'm going to write the coefficient out, separate from x. x squared plus a squared. So same thing here. As the limit, we have our, we still have our oblique asymptotes like this. But this time, notice, if we do the limit thing, we're taking away this plus a squared term. So our approximation is slightly below where the actual graph is because we took away this a squared, which would mean that it's actually going to be slightly above our asymptote, which would make it a vertical one. So, but again, that's not as important. If you see it, cool. I'm glad you see it. I hope you think it's as cool as I do. If you don't see it, not a big deal. But again, the main takeaway, I'll write it over here in green though. So the equation for these asymptotes, notice if we take the square root of a squared over b squared times x squared, it'll be the same thing as we did here, just it'll be a over b instead of b over a. So y equals a over b times x, and y equals negative a over b times x. Any questions? And that's for your vertical. The green is the vertical, the blue is horizontal. All good? You guys ready to finish your homework? No. Okay, we're going to do a couple examples of this so you guys can see like some actual numbers built in because I know a lot of people learn better that way. I definitely do. So I feel you there. So let's do a couple examples. So, I'm going to ask you guys, let's find the standard form of an equation based on a couple of things that you're given. So in this case, I'm going to give that we have the vertices. We know that the vertices of our hyperbola are at 0, -3, and at 0, 3. And then we also are given that the asymptotes are at y equals 2x and y equals -2x. So we have the vertices, we have the asymptotes. First thing we want to do is say, well, if we need to write the standard form, that's our ultimate goal, is to write the standard form, or write this equation in standard form. We need to know if it's horizontal or vertical, right? Because those are two different standard forms. So the easiest way to tell if it's horizontal or vertical is to look at the vertices and see if the vertices are focused on the y values or on the x values. Because notice, and remember that this is under the assumption that h and k are 0. If we're centered at 0, or if you've already applied your shift, then you look at your vertices and you say, okay, is the transverse axis up and down or is it left to right? So, because notice on our vertices equations, for the vertical form we have 0, a, and then for the horizontal form we have a, 0. Correct? So here, based on that, would this be vertical or horizontal? Vertical. Good. Because we have the y values are 3, but the x values are 0. And what that looks like on a graph is the point 0, 3, the point 0, -3. So we know it's going to look like this. So we know it's vertical. Now the other thing is, where is the center? Yeah, 0, 0. It's the midpoint. With a graph, it's easy to see that. So 0, 0. So we have the center. We have the I don't know what the word would be. We know it's vertical. So the standard form of the vertical equation is y is positive. It's easy to remember. Y is always your y value, right? Makes sense. Y is always your vertical value. It's your y value. So if y is positive, it's your vertical value. If x it's your vertical hyperbola. If x is positive, it'll be your horizontal hyperbola. Make sense? So whichever one's positive, that variable corresponds to either vertical or horizontal hyperbola. Okay, so y squared minus k, or y minus k, sorry. Y minus k squared over a squared minus x minus h squared over b squared equals 1. Now we said we're centered at 0, so h and k are both going to be 0. And then we said that our vertices always have the value 0a, or 0 -a, for for a vertical one, right? So a value then would be 3, because we have 0a, which is 3, and 0 negative a, which is negative 3. So a equals 3. So I'm going to rewrite this whole thing. I'm going to just take away the k and the h. I'm not going to write x minus 0 or y minus 0. So just y squared, 0 is implied, over a squared. A is 3, so a squared is 9, minus x squared, implied 0, over b squared equals 1. So after looking at the vertices, we can just say right off the bat, we only have one more variable to solve for. We just need to find b squared. And we're given the asymptotes. So if we're given the asymptotes and we have our asymptote formulas memorized, which I highly encourage you to do because they won't be on your formula sheet. For the test, I'll repeat, for the test, these will not be on your formula sheet. The asymptotes. So got to pull that careful one. Okay. So we're doing a vertical one. So the equation for our asymptote is y is equal to a over bx. So we can write that y equals a over b times x. And we're given that one of our asymptotes is y equals 2x, right? So we're going to write that right below it, y equals 2x. So we know 2 has to take the form a over b. So we could say a over b equals 2. And then we know our a value, which was 3, because a squared is 9. So our a value was 3. So we can plug in a 3, and we get 3 over b equals 2. Pull b over to both sides, you get 3 equals 2 times b. Divide by 2, you get b equals 3 over 2. Right? So b is 3 over 2. Throw that in here. 3 over 2 squared, 9 over 4, because you square the top and the bottom. And then this is correct. If you wrote this, you'd be 100% correct. But a better way to write it is to multiply by the reciprocal. So instead of dividing by 9 over 4, we're just going to multiply by 4 over 9. Same thing. But if you leave it in the bottom, that's okay, but that looks nicer. So, questions? I'm sure there's some. Don't be afraid to ask. So you all are smart, you know what you're doing, hundreds on the test?
Is it part of it? Yeah.
Is that a 9 on the bottom?
That is a 9, sorry. Alright, we'll do another example. Alright, let's let our vertices do a different color. Vertices will be 1, 0, and negative 1, 0. Nice. Asymptotes will be y equals 4x and y equals negative 4x. So, first step. I'll let you guys guide me through. What's the first step?
Notice it's horizontal.
Yes. Note if it's vertical or horizontal, the x values here are 1 and negative 1. So if you look at it on a graph, that's here and here, which means it's going to be horizontal like this. And then what's the second thing we should notice? Whoa. There we go. What's the second thing to notice?
The origin.
What about the origin?
It's the center.
Yeah, it's the center of the hyperbola is the origin, because it's the midpoint of those two vertices. Okay, there's a lot of chatter back there. Thanks. Okay, so we have the center is at 0, 0. We have that it's horizontal. And why did we need to find that it was horizontal? Yeah, so that we can know which standard form is correct. And in the standard form, is x positive for horizontal or is y positive?
X is positive.
X is positive if it's horizontal. So we have x minus h squared over a squared minus y minus k squared.
Wouldn't it just, I thought it'd be x over e squared because it was just 0, 0.
It is.
Doing that.
Oh, you're
I'm just writing out and then I'm going to rewrite it, just like I did over there. But yeah, that's correct. So this is our general form, and then we know our HK, and we know our A too, right? Because the vertices take this form. Here we see the horizontal vertices are A0 and negative A0. Here we have 1, 0 and negative 1, 0. So, and remember that is only for center at 0 or after you move your shift. I can't stress that enough. So rewriting this. H is 0, so x squared over A is 1. It will. I'm going to write it out though, so everyone can see where it came from. But yeah, you don't have to write it at all. So you get x squared over 1 squared, or just x squared, minus y squared over b squared equals 1. And then how are we going to find b?
Do the little formula thing. B over A.
Yes, so in this case, we're going to use the horizontal formula, because this is a horizontal hyperbola. So it's b over a instead of a over b. So we can write that out, y equals b over a, x. And then we're given that the asymptote is y equals 4x.
It's the distance from the.
So if you substitute, 4 equals b over a. I should say 4 has to equal b over a, based on the formula. And then we're given that a is 1. So b over 1 is just b.
So you use 4.
So b equals 4. And we can plug that in. So I'll rewrite the whole thing down here.
X squared minus y squared
Equals 1.
Good. Cool. Questions? All right, we've got enough time for like one more example. I'm gonna let you guys do one together. Exit ticket. Alright,
I'm done right now.
it'll be like an informal exit ticket.
Look at mom's
All right, guys. Bring it in. We're almost done. So, I want you guys to solve this problem on your own paper, alone. So you guys have to figure this one out yourselves. For your exit ticket, you got to show it to me before you leave. Or you can just leave, get up, walk away. That's cool.
No,
I know. I'm just messing.
Where are you going?
Okay, so I'm going to give you the vertices are 4, 0 and negative 4, 0. And then the asymptotes are y equals 3x and y equals negative 3x. So pull out your paper, solve this, show it to me, and you can pack up for the day.
Let's grind, guys.
I just wrote it. I don't really want to.
But I want to see you guys working alone on it, no partners this time.
Oh,
If you need help, ask me.
So being here alone.
That's so mean.
Yeah, that is mean.
I'm just being real.
I have so much brain power right now.
Where is he? I'm Google what a vertice is. Yes. It's on the paper. You're joking, right? No, you actually just what a vertice is.
No.
The vertices are Wait, so what are you supposed to graphic? The vertice formula. Yeah, so your vertices are there. And then, what are you doing? Oh, you forgot white? Alright, yeah, the white is negative 3. The asymptotes. So that's your sorry.
Yeah.
So those are those in your equation. So you have 3 over 1. So you have that.
Because one is it.
Yeah, you did it. Oh, I didn't realize.
Yeah.
Yeah.
It's gonna be like
Oh wait, then there's
Right, so I got 3 equals BAX.
None of the other terms.
Try again.
3 equals B over A.
Again.
And then you know what A is, correct?
Oh, got it. 3 equals B over 4. That's what? 16. Are you multiplying by 4? Look by 4. 12 equals B. Oh my god, we got it! X squared over 3 squared. Y squared over 12 squared equals B. Hey, I got that.
I'm done.
What'd you get?
For the
Actually, 3 squared.
Wait, what?
Oh, you stupid idiot.
No?
No, close your
It's
eyes.
4 squared. It's 4
Try
squared.
again.
So you're
Wait, let me see if you can.
No, Chloe. It's 4 squared. I got it. Wait, let me see. X squared over 4 squared minus Y squared. Y squared equals 1.
This guy was trying to get some other things.
I have 12.
Yeah, you're good. Okay, that's
Sorry, buddy. What's the answer? Yeah. You got it? Hey, I got that.
You're right.
Yeah, me
You just send that information.
Tomorrow? Yeah, I did 4 squared. Yeah. X squared over 4 squared minus Y squared over 12 squared equals 1. You told this story in this class. I'm not kidding. No, I already know.
The whole thing was shaking.
Yeah, you gotta have it. You don't? You turn it in?
Wait, I'm listening. You're saying that one is over top.
Yeah, no, hers says 3 I'm writing 4 years with the object. She was so mad. I was like,
I'm taking my first This is my first English class here.
This took my,
What's your first class on this?
one freshman year,
Wait, where's
2 last year, and 3 this year.
003.
How many taking this year? Like, which ones?
I got it right.
you got
Actually, not my own.
good job.
For the most part.
Nine.
I